So this is going to be part 5 of the Geometry Common Core Review Guide. Like I said before, you can purchase this on Teachers Pay Teachers if you are currently not one of my students. And we're going to focus on 16 to 20 in this video, so go ahead and turn to page 39. So on page 39 we talk about parallel and perpendicular lines. I go through some of the definitions. We have parallel, perpendicular, intersecting, and skew lines. But the main focus in this section is to determine parallel and perpendicular. So parallel lines have the same slope, and again we're using the y equals mx plus b, so m would be the slope. Now if you don't have that y equals mx plus b form, then you're going to have to get it in that form. So we're going to look at question 1. They give us this equation, 4x minus 3y equals 12. Now, the problem with finding the slope right now is that it's not in that y equals form. So to do that, you're going to have to move first the x term, and it's positive 4x, so we're going to subtract 4x on both sides. So make sure that you keep the terms separate. And then I generally write it in the same form, so I'll put the term with the x first. And you can divide by -3. So what I would do in the calculator, once I got to this step, is I take my two numbers, my -4, and I would divide each of them by -3. So that would be my first step right here. I get a decimal, I change it back to a fraction. So I have y equals 4 over 3x, which 4 over 3, that would be my slope. And then I would do the other one, which is 12 divided by -3. Now this part's not necessary, but I'm showing you anyhow because sometimes you're going to have to know how to do that, especially with graphing equations. So the slope of that is 4/3. Now if I wanted parallel, I would be looking for 4/3, but it says in the question perpendicular, and like it says up in the notes at the top, the slopes have to multiply to -1. So you have to take the opposite sign and flip the fraction. So if our original slope is 4/3, then a perpendicular slope would have to be -3 over 4. So that's what you're going to have to do if you don't see y by itself, is get that y by itself. And I notice right now that with question 1, I don't see a -3 over 4 on the two that have y by itself, so I'm going to have to take and rearrange C and D and see which one gives me that fraction. So moving on from there, you're going to use, at the bottom of the page, you'll see a diagram. It's a pentagonal prism. Now it says what each letter represents. P is parallel, S skew, and I intersecting. So I'm going to look at question A. We got A, B, and G, F. So you want to find those two. So here's A, B. Here's G, F. See the little lines that represent parallel. And then you just want to circle which one you believe it is. Remember, skew lines go in different directions and don't touch, and intersecting lines go in different directions but do touch. So make sure you circle each one of those correctly, and then check your answers over. Now we're going to write an equation. It'll be the last one we do together in this section. So they want us for question 8a to write an equation that's perpendicular to a point, and they give us this equation they want it perpendicular to. So we're going to use the equation, the standard form of equation of a line. This formula here for each of these. So I need to put in my m value, my slope. Well, the slope for this is 1/4, so the perpendicular slope I'd have to use would be -4 over 1, or -4. So when I write this out, I'm going to have y, then I have my x1 and y1, y minus 7, and that's going to equal -4 parentheses x plus 4. Notice that I had to change the sign because I got a minus sign in the formula, and then I got a negative number. So you want to distribute. So you end up with this, and then you want to get y by itself by adding 7. That gets added to that last number. So then you get y equals negative 4x minus 9. And then a quick way to check it is to go to y equals, actually put in the equation. So negative 4x. And hit second in graph. You can go to the table, see if that point's in there. So you got negative 4, 7. It's on that line. So we should be safe and good to go with that one. So let's go ahead and move on to the next section. Which talks about line partitions. So with line partitions, you're talking about ratios. It says a ratio of 2 to 3 for AB. So we're looking for which one of these is broken into 5 parts. There's 5 total parts. And we're looking for that point to be 2 parts in of those 5. So in this case, if I look at A, well, A is actually only 2 to 1 because there's 2 sections before the point and then 1 section after it. And then B, I have 2 sections before it, 2, and then 3 sections after it. So that's going to be my answer. Be choice B. Now we're going to look at one of the more difficult questions for this section. If you go to the back of this page, question 8. Determine the point P that partitions the directed line segment AB into a ratio of 1 to 3. So to do this, we need to figure out the scale factor. So K, in this case, is that first part over the total, which would be 1/4. Now we have A and B, and what we want to do for this section is we're taking a dilation of 1/4 from that original point, which in this case is 2/3. So how this will look is we'll have our first number in each part of the parentheses, and we're going to be adding to that first number the scale factor, and then in the parentheses next to the 1/4, it's going to go the change in the x, the run, and the change in the y, which is the rise. So I need to find the differences between those 2 points. So I notice that from 3 to 11 I'm going up 8, and 2 to 14 I'm going up 12. So if my change in my x's is going to be 12, which would be my run. Change in y's would be my 8. And then what you can do is take this, each expression, put it in the calculator to give you what, and we'll call it, in this case, P. What point P is the partition point. So that's how you would get the answer for 8, similar to 9. Okay. And this part right here, how I found K, because 4 is the total, that'll help you with the questions above 6 and 7. So, moving on from there. Talk about circle similarities. Now I'm going to illustrate this one with one of the questions that comes with a graph. So we're going to do 6A. So what we need to figure out is how to get the first circle to exactly fit on top of the second circle. So we need a translation vector, they call it. So we're going to move it based on the distance from A to B. So in this case, I'm going to have to go over 9 spaces to the right. So I translate it 9, and then down 1, which would be -1. Now the last part I need to figure out is how much bigger do I have to make this circle. So I know I have to translate it from 9. I need to figure out the radius for each of these. So in this case, this is 3 for a radius, and then the radius for B is 5. So if I want to make it the same size, I'm going to have to divide those two which would make my scale factor 5 over 3. So it's a combination of a translation and a dilation to get those similar circles to be an exact match. So let's move on from there. We got 2 more sections. Now I strongly recommend looking at and reading all the properties that deal with circles. We're going to look at a couple. We're going to look at some that deal with angles and some that deal with side lengths. So we have 2 similar circles with angles located inside. So what they're asking us to do here is find the measurements of a certain arc. So like for this one, the measurement of arc BC. Well, BC would be this arc right here, and that's going to match that central angle. So that one would just be 70 degrees. And then, for example, if you take arc GEK, well, arc GEK would go from G, passes through E, stops at K. Now I have 25 and 70 as angle measurements, so I'm going to have to subtract those from the total of, which would be 360. So if I do 360 minus 95, that's going to give me the answer for C, which would be 265 degrees. 265 in this case. Okay. Now we're going to look at some other measurements. Let's deal with sides. One of them I want to talk about is 8. Okay, we have a triangle that's outside and the circle is located inside it. So now when they tell us that AB is 8, I'm going to mark that 8, but because it's a tangent line, I can also mark the other tangent line that touches that circle 8. So I know right now that AF is also going to be 8. Similar to that AE, they just told us AE is 20. So if that whole thing's 20, then this part would have to be 12, which then you got another piece that would be 12, so you can fill that part in. Okay. And eventually they just want you to work to whatever answer it states in the question. So labeling is important in these sections. Now the last part I want to look at, if you go down to, there we go, determine the value of x. So we have, in this case, we have several different questions. We're going to look at question B. So we need to figure out an answer for x and for y. Now I can figure out x. I know that x is 3 because this radius is 15, so that means that these 2 pieces have to be 15. So I know that x in this case would be 3. Now I'm going to use one of the formulas from the arc page that we talked about in the directions. So in this case we got 27. If we take the cross products, in this case 27 times 3, and we set that equal to the multiplication of the other 2 parts of that chord, 18 times y. We can figure out what y is by multiplying these together. So we get 81 equals 18y, and then divide each side by 18. So that's going to end up being 4.5 for y. Now similar for 15, we got either secants, or in the case of tangent lines, you might see some tangent lines involved. But if you look at, let's stick with B on this one also, it should be the whole entire minus the exterior. So in this case this would be 16 times 64 would be equal to 15 times x plus 15. Then you multiply and then solve for x in that case. So this one that says to round to 2 decimals, which if it does, make sure you do round it correctly. Now the last part that we're going to look at, it's going to be the very final page. So if you look at question 3b, now the formula's on the page before this. We're going to find the arc length. And it says on the page before it, the arc length is going to be theta times r. So theta is 2 pi over 3 times the radius, which in this case is 6. So if you multiply those numbers together to get the exact answer, it would be 12 pi over 3, which would end up being just 4 pi. So that would be the arc length from here to here. Notice that some of them have area. Some ask for the arc length. Just make sure you read the questions carefully and use the correct formula. Okay? So I hope this was helpful for those sections. And if you have any questions, see me in class, or feel free to message me.